Hello and welcome techies. I am Sambhav here. This is the second part of data type. In the first part of data type, we have talked about generic data types. What is the significance of data types? Why do we need data type in SQL? We have also talked in detail about the Boolean data types. In case you have not watched my previous videos on SQL, please go ahead and check them out. I will leave the link in the description for you. In today's session, we are going to mostly talk about the numeric data types. So general data type is what I have already showcased to you in our previous videos. Today we are going to talk about number data types, and we are going to discuss in detail about the integer data type. We are also going to have some practical demo. In the previous video, we have also talked about all this data type. So Boolean we have, numeric, character, date time, UUID, JSON, arrays, edge stores, network address, enumerated. We are going to talk about all these data types in detail. In upcoming videos, we will talk about all these data types in detail with real-time practical example. In the previous video, we have already discussed how Boolean data type works and what it is. So in today's session, we are going to talk about numeric data type. Numeric data type. Now, the first thing which pops up in our mind about the numeric data type is what are the different types of numeric values we have. So let's say when we talk about numeric data type, right? Numeric data type, it can be mostly of two types, right? Sorry about my writing. The first type I can say integer value. The first integer value. The second could be decimal value. The second one is of decimal values. If we look at any number, it can be broadly categorized into two types, integer and decimal. Integer means the whole numbers, non-decimal numbers. For example, 10, it is an integer number. 15 is an integer number. Minus 300 is an integer number. So here we are talking about non-decimal numbers, the whole numbers. When it comes to decimal, we are going to talk about numbers with decimal points. Let's say 2.5 is a decimal number. Minus 3.676 is a decimal number, right? So when we talk about numeric data type, it can be broadly categorized into two types: integer, which stores the whole numbers, non-decimal numbers, and the decimals, which has got the decimal values, right? Now, in order to simplify the study, SQL has provided various data types. So numeric data types can be mainly categorized into four types: integer, floating point numbers, arbitrary precisions, and serial types. But now you would say that just now we discussed that there are only two data types. Numeric data types can be broadly categorized into two data types. But right now we are talking about four. What is the meaning of it? Now let me explain it to you here. Let me remove this part. We don't need this anymore. So let me remove this piece here itself. And so these are the four data types we discussed. Now when we talk about integer, right? So this is a straightforward, it is an integer value, right? Int. Floating point number are nothing but decimal. Floating point number are nothing but decimal. Arbitrary precision number is also representation of decimal number, and serial data type is again an integer. So ultimately, when we talk about numeric data type, it boils down to two types: integer and decimal. So integer is nothing but integer number. Serial type also is nothing but representation of integer. It is an auto-generated number. We will see in our upcoming videos. When we talk about decimal, so these two are nothing but the representation of decimal numbers, which is floating point types and arbitrary precision numbers, which we are going to see in our upcoming videos in detail. And it is really very important. Now, talking about integer data type. So today we will restrict our discussion only about the integer data type. Now, talking about integer data type, SQL has provided us three types of data types in PostgreSQL: SMALLINT, integer or int, and BIGINT. Now they all hold integer numbers. There is no difference in terms of types of value which they store. They are the same in terms of type of value. In small int also hold integer numbers, integer also hold integer numbers, BIGINT also hold integer numbers. Then what is the difference? The difference is in the storage size. That means small int can hold values only up to 2 bytes, whereas integer can hold values up to 4 bytes, and big int can hold value up to 8 bytes. Now, when I'm talking about 2 bytes, 4 bytes, and 8 bytes, you might be a bit confused. So let me bring this here. Now, what is the meaning of it? The moment I say small int can hold value up to 2 bytes, which means that the value range is from minus 32,768 to plus 32,767. That means any value within this range, let's say 10, so 10 fall within this range. Let's say 3,000, it falls within this range. It means this is the maximum limit. That means the lowest value which you can store in small int is 32,000 minus 32,768, and the highest value which you can store in small int is 32,768, sorry, 67 plus, right? And in order to store this range of value, any value within this range, 2 bytes will be consumed. But if you have, or if you need to store larger values, then small int is not good for that. Then you will have to switch to integer or int. Int is just the double of, just the double storage size of your small int. So small int has 2 bytes, this has 4 bytes. And as you see, since the storage size has doubled, you see the range of value, it has increased drastically, right? Similarly, when it comes to big int, it stores 8 bytes. That means a very large integer number. That means this is the positive integer value range. Sorry, negative. This is negative, my bad. Please remember this is negative and this is your positive. So if you talk about the type of value which these three data types stores, they are same, which is integer value itself, but the difference is in the storage size. Small int can hold 2 bytes and the range is minus 32,768 to plus 32,767, whereas integer can hold up to 4 bytes and this is the range of it, whereas big int can hold 8 bytes and this is the range of it, right? So the only difference, the difference which you will notice here is only in terms of the storage size, and it is pretty easy to remember. Starts with small int, which is 2 bytes, integer is the next one, which is just the double of it, and big int is just the double of the previous, which is your 8 bytes. So 2 bytes, 4 bytes, and 8 bytes. Now, let's do some practical to understand this. So now since we have understood what an integer data type stores, it stores an integer value, right? So there are a few important points for us to remember. The first point is it stores the whole number. Now let me show you all these points practically. There are a lot of interesting things about the integer data type which you must be knowing. So let me create a simple table. This table name is int underscore tbl and it has got 3 columns: ID, serial number, and barcode, and I have defined a different data type for each one of them. ID is a small int which is going to hold only 2 bytes of data, whereas serial number is an integer data type which can hold 4 bytes of data. Barcode is a big int which can store 8 bytes of data, which is a very large number. So let me go ahead and execute this piece of code. I have executed this. Now let me refresh here on my table so that I should be able to see the table. Now this table has got 3 columns: ID, serial number, and barcode, what we have created just now. Let me execute the select statement so that I can look into my data. But since we have not stored any data into it, you will see that there is no rows inserted. Now in the first case, I'm inserting the values. In the first case, I'm inserting some values, and I'm inserting the values for ID, which is a small int, serial number, which is an integer, which is of integer data type, which is of 4 bytes, whereas barcode is a big int which is of 8 bytes. So I am inserting the values within the range. We have already discussed about the range. So small int is going to have 2 bytes and it is within the range minus 32,768 to 32,767. So this is the range. I'm inserting negative numbers. Let me insert one positive number also here, because that falls within the range of small int. Now the moment I execute it, 2 rows of data will be inserted, no problem at all. Now you see I have this value. So ID is 10 and 32,000, and you see serial number is storing a bigger value definitely, and BIGINT is storing much bigger value for the barcode. Now it is not that a barcode which is a BIGINT cannot store small values. It can, it definitely can. Let me show you with a small example. Let me insert one more row here, and let me just delete this piece, and let me insert a very small value for each one of them. Let's say 1, and let's say here I'm inserting just 2, and here I'm just inserting 3, a very small number, right? Now even though we have defined serial number to be as integer, which is 4 bytes, barcode to be as 8 bytes, which is a big int, but still we are inserting a very small number. So even if I execute this, you will be able to see the data. Now what is that we have done here? We have inserted a very small value. But if we know that we are going to insert a very small value in a particular column, let's say for example, I know that for sure my serial number is going to be 1 to 100. There is no point for me to define integer data type. Or suppose for example barcode, I know my value is going to be from minus 1000 to 1000. Assume I know that my barcode ranges only from minus 1000 to 1000. Now this minus 1000 to 1000 can be easily accommodated in integer data type. But I have defined a big int which is a data type. So what is the problem? The memory consumption will increase. So it is really important for you to choose your data type wisely. You must know what is the range of values your integer data type is going to hold. If then only you should decide on the right data type. Deciding the right data type is very important, because it definitely impacts the performance. It helps you, saves a lot of memory, which we have discussed in our last session, right? Now let us insert values out of range. Now for example, we know that for ID, which is a small int, can store value only from minus 32,768 to 32,767, right? This is a range of it. This is a range of small int, right? But you notice here I am storing a very large value here. I am storing a very large value here, which is out of the range of small int. In such situation, what will happen? The moment I try to execute or enter, the moment I try to enter a value which is out of range of that particular data type, SQL engine will throw an error. It will say small int is out of range. So you should also be careful while defining the data type, that you must know what is the highest value which you are going to store. Otherwise you will land up in problem. For example, here I wanted to store this value, but by mistake, assume I have defined this to be a small int, and now I cannot store that value, right? Now another important point is integer data type. If you have defined a particular table which is of integer data type, it can definitely hold null values irrespective of small int, big int, or int. Now if I look into my table, select star from int table, you would notice that the null value has been inserted here, because I have inserted null value for the serial number. So integer data type can always store null values as well, right? Now the question is, what will happen if I try to store decimal numbers? What will happen if I try to store decimal number in the integer column? So in this example, you would notice that I am trying to store 20.4 in the ID column, but the data type I have defined is small int. What will happen? This is a common question asked in the interview. What happens if you try to insert a decimal value to the column or inside a column which is defined as integer? Let's execute and see this result. So here also you see, for the barcode I am trying to insert some decimal values. Barcode I am trying to insert some decimal values. Now the moment I execute this, what PostgreSQL will do is it will store the integer part. Now you would be surprised that wow, it is not throwing any error irrespective of these values being decimal. And though we have defined that particular column to be as integer table. Now let me execute and show you the result. So the result is 20. So we tried storing 20.4, which is a decimal number, but in the output we are seeing 20. Similarly, if you see here, I have tried storing this number, but I am only seeing the numeric integer part. The decimal part is not stored. Then the question comes, that means first thing we are very clear that even though we try to store decimal values, PostgreSQL will accept, it will not throw an error, but it will store the integer value. Then the next question comes that how does SQL decide what to store? Let's say 20.4, so it has stored 20. For this value, it has stored 85. So what value is it actually storing? Is it like it is trimming out the decimal part? Is it trimming out this part and storing only the integer part, or it is rounding it off? Let me show you with another example. So in this example, I am trying to store two values. One is 46.6, another is 46.4, right? Now let me insert this and show you the result. So definitely we know that SQL will store this without throwing an error. We have seen that in our previous section. Now let me execute this piece of code. Now you'll be surprised that for these two values, first 46.6 has been stored as 47. 46.4 is stored as 46. So what Postgres is doing is it is rounding off the value. So remember, this point is very, very important. Whenever you are trying to insert a decimal value in an integer column, PostgreSQL will accept it, and while storing it, it will round it off. That means if the value is 5 or greater than 5, then the next higher value, that means 47, will be inserted. If the value is less than 5, then the previous, that means the value will be as it is, that is 46. So this is again a very, very important point for us to remember. So we have already seen it accepts nulls, and decimal values are rounded and stored as integer. So this also we have seen. Now another question is, what happens if I try to store any other value apart from integer or decimal? That means here I'm trying to store character value. Now let me execute this piece of code. So here what I'm trying to do, I'm trying to store hello for serial number. You will notice PostgreSQL has thrown an error. Hey, hello is not an integer data type. Hello is not an integer data type. So you will not be able to store integer any other data type here apart from numbers. So if we have to conclude what type of values integer data type is able to store, so it is very simple. It is integer values. It stores all the integer value. It stores all the integer or the whole numbers. When it comes to decimals, decimal values, of course it stores them, but it does the rounding off. So round off is performed on this, right? Apart from that, it can also store null value. So we have seen that it can also store null value, but it cannot store any other value. This integer is allowed, decimal is allowed with rounding off, null is also allowed. But if you try to store a string, right? If you are trying to store a string value, it will not store. If you are trying to store any character value, in fact, it will not store. We have seen that practically. Now, once your data is stored, let me pull up the table once here. Let me pull up this table, right? Now, When you define your column to be as integer data type, you can definitely perform mathematical operations, right? Let me give you a small example. So I'm trying to find the sum of ID. Of course, finding the sum of ID doesn't make sense, but this is just a fictitious example for us to understand that all the mathematical operations are applicable. So if I execute this, you see it will return a single value and it will say the total sum is 32,304. So whenever you define any column as integer or numeric data type, you can definitely perform numeric functions. You can definitely apply any kind of numeric functions from SQL, no problem at all. So I hope you have enjoyed this session. And if you want to continue learning SQL or Python, data science, machine learning, or AI with me, please like and subscribe my channel. Also hit the bell icon to receive notifications for my upcoming video. Thank you so much for your time and you have a wonderful day ahead. Thank you.